All right, we're going to learn and how to use the coproc command on Linux. If you're familiar with the coproc command, amazing. It's amazing that you know about that because I don't use this command often. In fact, I have hardly ever used this command, and it turns out it's going to be very useful for the thing that I was trying to achieve earlier today. The coproc command in Linux is a command that you can run in Linux that will capture the process ID out from another command and convert it into an asynchronous input-output. It creates two separate file descriptors, one for input and one for output for that process. And it's the exact thing that I needed for my test that I want to run to see how fast my MCP server boots. How fast does my MCP server boot? And we can find how fast it boots by using coproc because it lets us capture the output from the MCP server. But before output can be received, we need to also receive input. It needs to receive input first. So here's the command that actually will performs the task that we want. Hey, how's it going, SAQ 3000? You know what, SAQ 3000? I was thinking about the thing that you were talking about just a little while ago, just like a moment ago, about an algorithm that can break other algorithms. And thanks. This is an enjoyable stream. That's good to hear. Thank you. And I wanted to make sure that I properly understood what your question was because I wasn't getting it. You were like, I wasn't figuring out what were you talking about. But it kind of made sense, but maybe I wasn't fully understanding. Let me know. Let me know if you're still thinking about that because I'd still like to chat more about it. But right now, while we're here, we are going to get our we're gonna do this thing first. Exit. Here we go. Let's see. I want to run this to make sure it works first. Let's go ahead and do that. ls chmod plus x. It's called, what is this called? This is called test boot. Test underscore boot. Test boot. Here we go. All right. // test boot. Is it gonna do the thing? Is it? Oh no. That he had a little bit of an issue there. Here we go. Let's do that. All right. So bash. All right. So let's see here. Is this? Oh no, it needs to be ZSH. There we go. That might be a problem because we're using Z shell here. Let's see. Okay, so that worked, but it didn't. I didn't see any output. So let's go ahead and let's see. Let's make sure this still works. So we can run that command. Okay, that command looks good. We can see the output. We can see what we're looking for here. So what I'd like to do is convert this into a script that we could run locally, and make it good. So we'll see. My proc. So the command is going to be. So we'll go ahead and update it. So we're running npx. We probably don't need to redirect any. I'm pretty sure we don't need to redirect anything. So let's go ahead and comment that out. Get rid of the exit, and then we've got. We want to. What is our payload? We want to get our payload going. So our payload is going to look like this. This is what our payload is. So we can copy this really quick. Let's grab our payload. Oh yeah, I had and saw how the photonics work. Oh, you're talking about like a photonic chip, like the processor. Give me a good algorithmic trading strategy idea I could build. Okay, I will. Kyle, let me think about that for a second. I'll think about it for a second, Cal. Okay, SAQ 3000, but it's not the idea I had. You were thinking you could be even faster and want to combine it with generic algorithms or not. Okay. So yeah, with the photonic processor, the problem is, they're not really built for like necessarily really fast or performance or like brute forcing or capabilities that could factorize large numbers. They are built for efficiency, right? They're built for efficiency. These processors, they're really good at computing certain tasks without generating heat. So because it's just all light and it's light, I believe it's light and there's intersections of light that can then calculate like, what is it? Interference patterns, which then immediately get you an answer. Like it can multiply numbers very easily. I don't know if it can factorize numbers, but it can do it. But it can do it without generating heat. So you don't need like a heat sink or any cooling because these processors are just like light beams flowing across rather than having any impedance or resistance with transistors where it generates heat. And so you have to cool it off. But I don't know. It does sound like there is a possibility, SAQ 3000, what you're describing. I think there's a possibility. Hey, DR2C, how's it going? So a strategy for a good algorithmic trading. I'm going to think about that for a second. Good. So, all right, number one, it depends on your strategy. So what are you targeting? Where do you want to profit? Are you going to do high frequency trading where you want to get like to the millisecond and you want to get the precision to get those decimal points? Are you going to try to get predict the future? Are you looking like 10 seconds in the future or maybe 30 seconds in the future? Like what do you want to do? How do you want to make decisions? And then are you doing what kind of assets are you trading? What are the securities that you're looking to trade? What are the securities you're looking to trade? So there's a whole bunch of ideas around that that will completely change how you build your algorithm. Any tips to write Java monologues? Wait, why do you want to write a Java monologue? What are you doing, DRC2 or 2C? What are you doing? I'm having 6-7 while typing at Yacht. I would really appreciate the help when making Theranos disappear. Wait, what are you doing? I don't know. I don't know if you're saying words that make sense. I think you're intentionally being interesting. Intentionally being interesting. They are slowing down the speeds to low speeds. I did a quick chat with AIs, and I'm correct. And Elvis B, cool. Hey, how's it going, Elvis B? Good to see you. Welcome on in. Good to have you here. Happy Tuesday. I would really appreciate the help when making. I already have that one. So you did a chat with the AI and analog systems to solve equations extremely fast. Yeah. So, thank you for the likes, you guys. I guess I don't know too much about that. I don't, as what you're describing, SAQ 3000, there might be things that you're describing that I haven't really dug into. I don't know for sure, but it is definitely fascinating, isn't it? It's a lot of fun to think about. I like thinking about those things. Help! My computer ate my leg. Oh no! I forgot to install an antivirus. It is overwriting my code. No! That's terrible! Oh no, wait. Here's the problem. The antivirus is the problem. If you have antivirus software on your computer, then you've got your own issue, because typically antivirus software is the issue these days. Let it assimilate you. You got it, Shimon. You got it. How do hackers code to make aim bots hack on Warzone? Oh, well, you can do it in a couple ways. You can do it some interesting ways. There's also some parity checks that happen. So you could override the TCP stream, right? So you could override the TCP. You could redirect the TCP stream on your or UDP stream, whatever it is. Rewrite the packets, and then you could also have you can intercept the packets that give you information about the location of users. Potentially, you could do things like that. Although, that's how I would do it. I would think of it from a network perspective. Terrible issue. Oh no. Hi, is this a computer programming channel? It is CB. This is a computer programming channel. Right now we're doing Bash, or a shell. We're doing some shell stuff. We're doing coproc. Right now. You should code hacks for me. That would be a lot of fun. I think that would be a lot of fun. Because we could get into any, if you wanted to, we could get into any system you want, and then you could win all the games. If you wanted to win all the games, though, you know what? You got to be careful though, because you can still be detected. You can be detected. Stephen, I mean that Photonics, the company that builds light-based CPUs, are building light-based digital systems. I'm curious and recommend you to search analog systems. Oh, okay. They're more powerful than the norm. Okay, let's do it. All right, let's do it. Use words. I know unknown 1%. Use words. Thank you for the likes, you guys. Is Bash an extension of Unix? It kind of. Bash is like its own or shell. It's like it's a shell, but you've also got these. So I'm using Z shell and Bash are very similar. They're the ability to call applications on the Linux operating system or Unix operating system, and then have the inputs and outputs interact with each other. And there's and you can basically piece together everything. It's very similar to a programming language. It's basically a programming language. You can almost write anything you want in Bash. Almost anything You want Bash. Yeah, most of the change. Hey, Torva, good to see you. Most of the time change in the packages sent to the server. What? Sent to the server cheating. Oh, it is. That's what it is, isn't it? It's the packets. It's the packets, you guys. If you want to cheat at a first-person shooter and you want to do it with low detection, you can write your own. See, that's the thing. You can't give it away. You have to write it yourself, because once you give it away, they're able to find it and detect it, and then other people start using it, and they see that there's a problem. They detect it. So you need to stay under the radar. You can't release your secret sauce. Okay, seriously, I want to ask, how do offline large language models actually work? I've been having a hard time on setting them up. Whenever I got work and don't have access to the internet, would really help even a little. Okay, so have you used Olama? Olama is really easy. Hello, how are you? I hope you're doing very well. I am, Ahmad. I'm doing good. Thank you for asking. We're doing Bash today. We're going to do some Bash. I want to write a program. We're going to write a program here that we've already got it here. You can already see the output is looking good right here. So you can see it benchmarks the boot time of our MCP server. It sees how fast it boots, and it works really well. So you can see here. Check it out. Right there. Boom. Oh, wait 1 second. Nope. There we go. This right here. There we go. See? And you can see a 160 milliseconds. It's pretty good. It's pretty good. I think it is pretty good. And so we're going to write a script that makes it good. We're going to make a script that makes it good. That's the plan. You study math, but you're looking for applications. What are some of the most commonly used applied math concepts used in programming, AI, and gaming? Those are the two. When you're talking about math in the real world and with software engineering, it's writing games, because physics and collision detection, there's a lot of math there, and artificial intelligence and statistics and data analysis. That's the collision of math. But if you're talking about industry, like enterprise software, you don't see a lot of math. In fact, on my screen right now, do you see any math at all? Do you see any math? You don't. You don't see any math because there's no math. Most of the time, when you're writing software for enterprise applications, there's no math. There's hardly any math at all. There's hardly any math, no math whatsoever, you guys. Isn't it crazy? I think it is. I think it's amazing. So SAQ 3000, I wanted to check out analog systems really quick. So we'll take a quick divergence. So let's go. Analog systems, faster than digital, something like that. Let's see what we come up with. Let's see what we come up with here. All right. Yes, analog system can be faster than a digital system for certain tasks because they operate on continuous signals rather than discrete steps. Oh, I'm starting to get it now. So if you have a sinusoidal signal, a sinusoidal signal will give you a nice smooth line that's going to, you could do circles, right? Infinity. It can have infinite precision. So if discrete steps, though, means that it needs to sample, right, over a time step based on how fast the transistors can flip and switch. So that's where the speed and the performance and the accuracy is improved over an analog system versus a digital system. That makes sense. Okay, SAQ 3000, I think we're a lot closer to the same page now. I think we're a lot closer. Thank you for the likes, guys. I heard they cost a lot to store. Oh, wait, they do? Wait, what are you talking about? Short running. So let me go back to the LLM conversation really quick. So just check out Olama. Go into Olama and then get GPT OSS and then run the 20 billion parameter model. Here you go. This is the one to do. This is what I recommend. This is it right here. Check it out. I think there you go. I think you'll have a very good time with this one. This is a good starting point. It's a good starting point, you guys. Hello, how are you? Hope you're doing well. Oh, sorry, I already read that. Thank you very much again. Stephen, analog equations solvers will be the end of any encryption and reality as we know it. Oh, no. Really? All right, well, we're at the whim. We got to be careful. Do you write in style of refusing loops? Wait, what? Hold on. Wait, what? What is this? What are refusing loops? Putting more stuff in loops but use up more variables? Or the other way, do you reuse some variables after using them for a price of losing the data? Oh, It depends. It really depends. If you're doing a lot of data churn, then you definitely want to overwrite, because you don't want to keep calling to the operating system to give you new memory addresses to allocate for more memory usage or deallocate. Because if you do that, that's a very high cost. System calls are not cheap. System calls are not cheap. You got to be careful. You want to make as few system calls as possible when you're writing your code. So if you're looking for performance, you want to reuse the data. And also loops, they're fine. Loops are fine. They're actually fine. I mean, they're perfectly fine. You got to be careful. Or just use Open Router. Wait, oh, AI live streams. Wait, where are you going? Hey, Wavy, how's it going? Good to see you. Oh, that actually is just the right way for, hold on, just the right way for hardware. Thanks. Okay, sounds good. As in, you can make a program with only a few variables by reusing them. Oh, got it. Yeah, okay. There you go. I mean, that's, if you're looking for the most efficient program, though, you got to be careful for mutability, right? Mutability, you got your problem is you have a chance of making mistakes, Simone. You got some chance of making mistakes. You got to be careful. I consider people who write codes are stupid. Okay, Explorer 649. That sounds fine. Codes are nothing but a bunch of meaningless words. I mean, they're a bunch of words. I could tell you that. They're definitely a bunch of words. Wait, you just got here. What do you do? Wait, laundry 123. Laundry 123. What do you mean? What do you mean, laundry? We're writing some code. We're writing some code. So I've got my MCP server. There we go. So coproc MCP server. Let's pipe. We need our. So let's see here. We need a. What do we call it? Let's go pay. Let's go tools. Let's just say tools. I like this idea. I like this idea better. So let's grab this really quick. There we go. Grab that. Tools done. All right, we got our tools. So let's see. Example JSON. It's not example. It's just the JSON RPC call to list our tools. There we go. JSON RPC call to list our tools. Got to get a little bit of a text typing in there. Sorry, I'm running out behind on our chat messages. I'm running behind on our chat messages, you guys. I'm overwhelmed by the amount of information here. My brain can't keep up. I wrote every very simple program to add 2 numbers in C language. That's quite an achievement for you. It is. Hey, you know what? It definitely is. C is not the easiest language. And if you're able to write some code in C, good job. You did it. That's actually really powerful. This is a good first step. Keep going. Don't stop there. Don't stop there. Most of the time, parameters are just stored in individual floats, which is why they're so small. Yes, Torva, you got it right. You got it right. You know what you're talking about. You know what you're talking about, Torva. AI expert, you guys. Torva. AI knows the AI. He definitely knows the AI. Femtosecond. Oh, femtosecond. I've heard about that word. Hold on. Wait. Femtosecond. Let's check it. Femtosecond. What is this? I remember this. Is it with an F? Okay. Femtosecond is a unit of time equal to 1/4 of a second. Okay. It's a very, very high resolution measurement of time is what that is. 1/4 of a second. Femtosecond. We got a bit femtosecond there. Multicolor light generator analog machine. This machine programmer equals beast. By the way, I don't think I'm a bad person. Please, hey, don't, not at all. You're a good person, SAQ 3000. You're good. You are a good person. I don't see any math, but I see a lot of language. I remember the Google PageRank was an application of a eigenvalue. An eigenvalue? What is that? Does math knowledge help with making novel programs? CB4891. You do not need math. You do not need math for the majority of computer software engineering because it's just not the case. You just don't need it because as you can see here, there's no math. There's hardly any math. Do you see any math? I don't see any math. There's no math there. Thanks, Torben and Steven, about the LLM. Excellent. Happy to help. I consider, I started using Python. All right, your laundry 123. Python is the greatest language that every software engineer should definitely learn. It is used in all of the industry for data science, for AI, for probably other things. I mean, those 2 things alone are huge. They're massive. They're amazing. Also, web servers. A whole bunch of other design patterns and things like that. A whole bunch of patterns. Codes are just enough powerful as words. They are, right? SAQ 3000. I think so. Why are you? I've been browsing your channel a bit. You're a legend. Thank you. Thank you for saying that's great to hear. Well, the easiest timeout in my life. Excellent. That's the way to do it. That's the way. I think so. All right, here we go. Let's get into our program. I want to make this program available to run in our test to make sure that we're running fast. What would be the best language to use making a website? Laundry? Depends. It depends. Probably, here's the most popular one, is Node.js and JavaScript. It's Node.js and JavaScript that is the most popular and most widely used for all internet web-based things. It's called Node.js and JavaScript. At Laundry123, Node.js and JavaScript. We have JavaScript here. We've got JavaScript here. There we go. JavaScript. There it is. There it is. Node.js and JavaScript. But also PHP is another server-side language that you would use. But you know what? If you got JavaScript, you're good to go. You got good to go. Okay. Okay. Cool. Here we go. All right, let's get into it. PHP is crying on the corner. No, because over the years, PHP it's still really good. It still does its thing, but you know what? It's other things have become more popular than PHP these days. You got Node.js and JavaScript definitely more popular. Is AI going to take away jobs in software development? It is a way. So it's taking over writing code. You see what we're doing right now on the screen is we're writing code, but the AI could do that way faster than me. They could do it like it could have already been done writing the code by now, and it would have already been perfectly fine. So, but you know what? I'm noticing an atrophy. If I let the AI do all the work for me, I start atrophying on my programming. And so I want to make sure that I keep up my skills, everyone. Hey, Steven, what are the patterns in computing? What are the patterns in computing? What do you mean, Sergio? Sergio Montana. The patterns in computing are every pattern you could possibly imagine. Your hopes and dreams can all be there. Everywhere is it going? Okay, here we go. All right, let's see if we can get this. All right, so I want to echo. Let's do this. Let's do print. Let's print our tools. Let's print our tools. Money tools. There we go. Let's print our tools over to our proc server. Do we need the quotes here? I don't think we need the quotes. There we go. Perfect. Satisfying. All right. Now, do we need anything else? Let me check. All right, so we got that. There's the command. So we get the process. Do we need the process ID? We might need to grab the process ID. Let me make sure to grab that. So once we do this, thank you for the likes, you guys. So yep, we need the PID. Here we go. Let's grab the PID. We need the process ID. Perfect. And then do we want to do that? No, I don't. I think we're just going to print straight on over to it. I think we're just going to print straight on over to it like that. And then we're going to grab my MCP server here. And then we don't need that anymore. Let's grab that. Let's clean some things up there. And then let's see, output sounds good. All right. As a beginner, would you recommend watching your Rust language courses? Yeah, I would if you want Rust. Although Rust is not a beginner-friendly language is one of the problems. It's not very beginner-friendly. What you want is probably, if you're going to do beginner stuff, is Python. If you're going to be doing some beginner stuff, you want to do Python. That is my recommendation because it's easy, it's clean, it's a language that everyone should be learning because it's so widely leveraged and used in data science, software engineering, for big data and artificial intelligence. Big data and artificial intelligence. Data analysis. That's what I recommend. That is what I recommend for you. Though if you want the Rust by example, there we go. And let me click on videos and then, hey, someone else came up above me. What? Learn a new programming language, Rust with you? Okay, so that looks like it's new. So I did do this. So here, at least I'm a number 2. Best way to learn. Wait 1 second. So we got, here, check it out. There we go. So you get Rust by example. We make it really easy. We walk through the docs. And so it's actually pretty straightforward. So if you want, we show how to print. We show how to print things. See, check it out. Very easy. Some easy things to get started with. Easy introductions. I forgot that I did that. It's been, how long has it been? 1 year ago. Wow. That's amazing. That is amazing. All right. Let's see here. Let's jump back to our code. Please type short. Yes. Because it makes it easy for reading. Great community here. Cool, CB. Thanks for the chat and good energy. Happy to help. Good to see you. I'm glad to have you here. It's a lot of fun to do software engineering. I love it. It's one of my favorite things. We need something about Vim. Ooh, Vim. We need some Vim. Yeah. So we've got Vim right here, so you can see Vim on the screen. You make it look so easy. Well, so the important thing is, here, check this out. All right, here, let's do this. All right, let's do some Vim. Vim Tutor. Type Vim Tutor. That's it. Boom. Just type Vim Tutor and you're good to go. Vim is a very powerful text editor, and then you can use your arrow keys. Use the arrow keys up and down, left and right. However, it's going to teach you that you want to navigate using J, K, H, and L on your keyboard, which is where your hand sort of rests. LOL, my grammar's too sus. Is it? I think your grammar's fine. I think you're doing fine on your grammar. Fed? Wait, what do you mean fed? What is fed? Oh, Rust or Python for processing high-frequency time series data. Okay, so if you're looking to do some if you're looking to build a critical system, with high frequency and minimal latency, you must use Rust or C. Those are your best options. If you're looking for something that can process large amounts of data and be perfectly fine, but might not be like best on latency, Python is perfectly fine. Python is excellent. There you go. Python is a good option. How can AI replace legends like you? Hey, I don't know, but it's already started. It's already started to do it. We're already replacing legends. I mean, they're already replacing everyone. It's already doing a good. So AIs today, they don't need to get any better. They don't need to get any better, you guys. They're already good enough. The thing that we need to do now, as I guess software engineers are going to engineer themselves out of a job. Software engineers, we're going to take the AI systems that exist today. They're already good enough. And what we need to do is leverage them to automate workflows and tasks. And then we're just replacing jobs left and right at that point. Isn't it amazing? The AI is out, the rate of AI capability is outpacing our ability to leverage it. Isn't that amazing? Isn't that amazing? AI rate of innovation outpaces our ability to fully leverage its capabilities. It's fully way better than what we're actually using it for right now. So get ready for the next couple of years. It's going to be a lot of fun. We're going to see some interesting things. We're nowhere near done yet. So yeah, if you want some Vim Tutor, just type Vim Tutor and you're good to go. And then it's going to say, press :Q exclamation point to quit. And then you want to jump back into Vim Tutor. And you can start over again. Press X to delete a character, right? So on your keyboard, press X. Just press X to delete. So you're deleting characters. Yeah, look at that. There you go. Press X. Or press, you could, what is it? D, right? D will delete lines. You press D to delete lines. Oh, press I to insert text. There you go. I character to insert text. What else we got? Press Shift A to append, right? Shift A will append data to the end of the line. So Shift A, there you go, right? Shift A. And then escape to get out of that. Isn't that neat? That's a neat one. What else we got? Oh, WQ will write the file and save. We don't want to do that though. We don't want to save. Yep, you get, that's the summary. And there we go. We just finished lesson 1. We just finished lesson 1 on Vim. Isn't that crazy? Isn't that amazing? Torva, really good ideas in here. Keep the conversation going. Yes, Torva, please. Absolutely. Torva's got has helped us a lot in our algorithmic trading because we were doing some pretty heavy AI stuff. Torva helped us a lot. Thank you, Torva. Thank you, Torva, for doing that. Stephen, what are you coding? SAQ 3000? Okay, so we were just going through Vim Tutor because it was requested. We did the first lesson. Right now, we're going to code a shell, a shell here that is going to be used to see how fast our MCP server launches. It's going to see how fast our MCP server launches. So we got our process ID, we got our tools. We're going to read a line, and then I want to kill the PID, money PID. There we go. Kill the PID. Probably. Wait, we need to do it here. Let's do it here. Let's do it there. All right. So we don't need my proc anymore. So my proc is now going to be called my MCP server. Right. So we're going to do this. Actually, you know what? Let's. I've got an idea. So colon % my proc will replace with MCP server. Boom. All right, there. We took care of. Wait, this is not a thing. So this is a thing. That's a thing. We don't need that. Okay, snipper looks good. All right. I think this might actually work now. I think this might work. All right. Let's see here. I'm gonna pull this. Oh, wait, are we good? I might need to. One second. I might need this. I might need this data here. Isn't there also some weird Chinese movie about people predicting some kind of drought, right? Or a drought with an analog computer? Is that what you're saying? A drought analog computer made by soldiers? Oh, there is. Yes. What is that called? It's the 3-body problem. Right? It's the 3-body problem. I think that's what you're talking about. Right? On Netflix. It was a really good 3-body problem. Netflix. Here we go. Netflix 3-body problem. Right here. Let's look at the images. Isn't it neat? All right. So there is like an army of people. Computer. Let's see. Computer army. Here we go. Let's see if we get here we go. See, is it right here? Isn't that neat? This is it. This is what you're talking about. I'm pretty sure this is what you're talking about. Look at that. These are all people. It looks like a processor, doesn't it? It looks like a processor. Yes, that one. That's the one. Okay. Should humans be afraid of AI? Humans should be very, very happy about AI because it's going to give us a lot of abundance. It's going to take care of a lot of the tedious tasks that no one ever wants to really do. It's going to take care of those tasks for us and make our lives a lot more easy. So it's gonna boost our quality of life. But it's not going to seem like it initially because our quality of life currently depends on labor, human labor, and that's where we think all of that comes from. So it's going to be weird. It's going to be weird for the next couple of years. Stephen, have you seen holograms, like real holograms in air? I've seen, yes, but only they're not real. They looked like they're holograms, but they're not actually holograms. What I think a real hologram would be is something like the holodeck, right? On Star Trek, where it has real, like you could really interact with the things and matter and stuff like that. So it's not a real hologram. But I've seen things that look like it, and they're pretty neat. They're pretty neat. Okay, here we go. Let's jump back to our code here. Let's jump back to our code because I would like to get this. I would like to add this into our repository. So I do need to read. So I got my read here, MCP server. Do I need to set IFS? I think we'll do this just in case. So we need to reset IFS, read lines, and then let's print it out, and then it's exit. Let's see if it runs. Do you think it'll run, you guys? I don't know if it will, but it seems like we got most of it done. I think we got most of it there. Let's see if it works. Let's see. Is it going to crash? All right, test boot. Let's see, test boot speed. Is it going to work? We got an error. We got a parse error near line 12. All right, 12. Let's go up here. Parse error. Oh, come on, really? It doesn't like this? Really? What do you mean parse error? Maybe this is a problem? No, that seems fine. That seems fine to me. I think we're looking good here. People should not be afraid of Alien. Allen Iverson at all, right? No reason to be afraid of Allen Iverson, you guys. We're all good to go here. AI. Oh, what's your opinion about this AI? Currently, we are just probabilities and statistics, but can we really call that intelligence? I mean, think about how your brain works, right? Isn't the thing in your brain kind of statistics and probabilities and how you're going to react next based on the input that you currently are receiving? Isn't it kind of statistics already? Right? Isn't it already? Oh, think about how your brain works. But will AI dumb down society? It kind of already is. It kind of already is because knowledge is no longer a thing, right? AI already has all the knowledge and you can capture the knowledge with AI and it's already there able to do it. So you don't, what's the point, right? So now is it going to dumb down society? And maybe in a, yes, it is. In a good way and a bad way, though, is I think the next question. Is AI going to dumb down society in a good way or a bad way? The answer is both. Because good way, because we don't have to deal with it anymore. Why? I'll just let the AI take care of it for us. In a bad way is now we're dependent on the AI at that point. So we won't be able to escape it. It's now our inevitable future. If you're looking into the black hole, the future is the new point fixed in time, and you cannot escape it. I think, yes, we can, because human intelligence is also just processing information in consideration of the parameters set by the past experiences. You got it, Torva. This is what I'm thinking too. People just ask AI questions and rely on AI knowledge. You got it, Aristotle. You got it, Aristotle 1, 2, 3, 4. Yep, Steven, no. I'm talking real hologram. Oh, see, light plasma, IRL. Search the video real quick. Fairy lights femtosecond. Okay, let's do it. Let's do it. Let's check it out. I want to see this. All right. Fairy lights femtosecond. All right. Is it? I think it's, femtosecond here. Is this it? Fairy lights femtosecond? Let's take a peek. Oh, looking pretty interesting here. All right, let's take a peek here. Let's zoom in. What are we looking at? Magnified image. Is that real? Someone made it? Someone really made this? Oh, neat. Volumetric container. Okay, so I think... Oh, whoa, no way. And you can... Oh, that's cool. That does count. That absolutely counts, doesn't it? Yeah, see, the kinds of holograms I've always seen on physical media. I've seen it always on physical media, but never some floating light beams. This is neat. SAQ 3000. Check it out. That is very satisfying. So check this out right here. All right, here we go. See, look. It looks like it's real light that you can actually touch. Whoa. That is neat. Look at that. Oh, they're printing. Okay, so I see what's going on. I don't at all. I have no idea how this works. It looks like it's definitely refracting off of something in the atmosphere, though, because if the atmosphere wasn't able to reflect it, you wouldn't be able to see anything. People marrying AI? Why? Why? AI will have human zoos? No, Aristotle. It has no ambitions, desires, or inspiration. It doesn't care about anything and doesn't have any hopes or dreams, at least as far as we know right now. As far as we know, this is really nifty. SAQ 3000, thank you. Thank you for taking it to the next step. Ooh, pretty. Oh, wow. I like that. That is nifty. As soon as it would be able to take control of the world, it would be superior. So, if it is, why would it keep us? Right, we're just ants at that point. Torva, man, this is cool. I know, that is cool, isn't it? So, Aristotle, if AI really was at the level that you're describing, it no longer cares about us because we're just ants. It's far beyond where we're at. Won't there be a point where AI intelligence is indistinguishable from human? Yeah, we're getting really close, aren't we? We're almost there right now. It's very close. In fact, we might already be there. Terminator. Oh, yeah, dystopian future. You got to be careful with those dystopian futures, Aristotle. You got to be careful because those dystopian futures, it is a potential, right? Skynet. Wait, the Skynet's coming. No, sorry, Steven, wrong video. Let me find the real video. I still think that was really neat what you showed. And what I want to show was, okay, post it on Discord. Post the link on Discord. SAQ 3000, post it on Discord. All right, so let me say exit. Let me see here. Let's see. Is that going to run perfectly fine? It is. Okay. All right, let's see. Exit. All right. Okay, so it doesn't like this. For whatever reason, it's not happy. It's not happy about that. Let's see if I can do that. Is that better? Unknown file attribute. All right, so maybe we can do something like that. Is that better? Command not found, of course. Of course. All right, so is that gonna do the trick? It doesn't like that. It doesn't like it. What if we did this? Bash. There we go. Is it better now? Coproc not even found. Coproc doesn't exist in Bash. It only exists in ZSH. ZSH. All right. So there we go. We created the thing that will destroy us. I know, didn't we? We're our own destiny. That we created our beginning and our end, at least. We created our end. We are the manifestation of the universe, and our only job is to observe ourselves, which is the universe. And we are going to de-observe. The de-observation could be happening soon. We don't know. When is it going to happen? Apparently, it's supposed to happen in 2028. So that's only like 2 years or so. That's only about 2 years away. Okay, so this is a problem. I want to be, so here's the command that I know works. I know this command works here. So this command right here works perfectly fine. What I can do is, instead of giving it a name, I can do this. So we can do this. I'm pretty sure that'll work. I'm pretty sure that'll work. So let's give that a shot. Okay. MCP command not found. Wait, really? Wait, really? Hold on. Let me try this. Node index.js. Let's try that really quick. Okay, so that works. But this should that won't work there because of I'm in the wrong directory. I got to be in a different directory, guys. Steven, search exactly this and click on the first video. All right, here we go. SAQ3000, are you ready? Are you ready? SAQ3000, here we go. AERL BU Arton true 3D display projects. Wait, project checks images into mid-air. Here we go. This video here. All right, let's check it out. Let's check it out. Oh, whoa, no way. Was this it right here? So they've gone to the next level. This is the next level. Is this real? Wait, this was 10 years. This was like 11 years ago. This is a long time ago. Yes, exactly it. Okay, this is the one. Okay. No way. So we've had this technology for a long time. Whoa. What do you know? It looks like, is this Japanese? It looks like it. It says Ikinamo. Ikinamo. It's real so sad. It's nowhere on Earth. Why isn't it? Why isn't this, is that like dangerous? Is it dangerous? It looks really cool. Oh, it's a butterfly. It's a butterfly. Check it out. Can't say that due to the rampant growth of tech. We just can't tell. It could be 1 year. It could be 10 or 100. Government only. Oh, that's what it is. Got it. All right. So the government says nope. Or just expensive. It could be expensive. It could just be really expensive. That's really cool looking. I like it. I like the sparkly. I like how sparkly it is. What is it? What is the shape? What is the shape? It could, is that, it looks like it's printing kanji. Or, no, it's a person. It's a person. They're drawing a person walking. That's kind of neat. That's pretty neat. I wanted to see it transported by car when developing this commercial product. So users can convert any suitable vehicle into a 3D display transporter. Oh, this is on the vehicle. No way. And then take display where it's needed. That's pretty neat. Suppression. Will there be good AI versus bad AI? There already kind of is. There already kind of is. This is neat. Look at this, a butterfly. It's really cool. So there is, I guess, good versus bad. So you've got good AI, which is highly censored and sort of holds back on information. And you got the bad AI, which is completely open. It's completely open, and it's to the world. It's completely open. So can't wait till my robot vacuum starts displaying 3D things in the air. I know 500 LRB. That would be neat. I think that would be pretty neat. It would be pretty. It's like not practical. Like, what would you ever use it for? This is very real hologram. Everyone seeks, but bro, it's nowhere to be used. It's not because it's neat. It's neat. It's pretty. It's awesome. What do you need it for? Like, what is it? What's the purpose? The purpose is awesome. 3D vacuum chokes you out in your sleep. Wait, does it? Wait, Aristotle, what? 3D? Oh, yeah, that's right. Because guess what? The 3D vacuum is coming for you. It's coming for you. It's got AI technologies, and it's going to get you. It's going to get you. All right, I need to, since I can only run proxy like this, I can't use the named, I need to use coproc process ID. What is the coproc process ID? Coproc default process ID variable ZSH. What is it? It is going to be called, is it called, I need the inputs and outputs though. I need, it's an array, right? Show how to use array PID, because it's a process. No, it's a file descriptor. I need the file descriptor ID, the file descriptor ID array, right? It's a file descriptor array. Purpose number 1. Screen less, which is bad for companies. Oh, Oh, you say. Is that what you mean? Okay. Oh, wow. Read, do, done. Okay. No, I need it to be, yes, this is it right here. Perfect. We got it. We got it, you guys. All right. So which one's which? Which one is the which? Exec C. Oh, so I guess we could use this. But I'm just going to use this. Which one? I guess we'll find out. We'll find out here. So that makes sense. I'm into the worst case scenario with AI. Sorry. Hey, no worries. I can tell. But you know what? It's called negativity bias. Aristotle, guess what? You're just like everyone else. Negativity bias. If you've been on this channel, we've been talking about this before. It's a good thing. It's actually a good thing. It sounds bad because we say negative. Negativity bias is a very good thing. Aristotle, you're on the right path because it helps us identify problems and things that we can make better in the future. It helps us make things better in the future. So you're doing it right. Do you know the difference between a resource and the tool in MCP? Because a tool can act as a resource based on the docs. You're right. It totally can. And I've done it before. So a tool can do everything. It can be a resource. It can be a prompt. It can call on systems. You don't need anything else. You don't need resources. You don't need prompts or templates. You just need tools. And your tool can do all those things. However, whatever reason they decided that they separated out tools and templates and prompts and things like that into their own category on the MCP server. You got it. You figured it out. But you're right. You're totally right. I also like asking questions to people who specialize in a topic that I don't understand. Aristotle, sounds good. Let's keep the questions coming. I mean, the FR want the fake everyone decades fake actions. Sounds like religious, but it's very evil. Taking everyone free actions. Uh-oh, SAQ 3000. Well, is replication legal or is it like patented? What is the stopping me from having hologram in my yard? I know, Turbo, what's stopping you? Seek yourself, haven't gone that deep. Okay. So apparently, okay, so here we go. I need this. So this is going to be, MCP server. All right. So I think all we have to do is grab this. Here we go. There we go. Just like that. All right. So what I need to do now is grab this, copy this, go like this, %s/MCP server. All right. We did it. There we go. All right. Now, I think we fixed it. And it's going to work now, isn't it? I'm pretty sure. All right, here we go. Do it public. Yeah, make it public. Torva, if you get a chance, make it public. No such file or directory. 17 and 20 file number expected. MCP command not found. Oh, all right. Oh, because we're in the wrong directory. Okay, so this is the problem. mkdir test. I'll see. Close that. MV test boot to test directory. Here we go. CD test. Now, can we do it? Can we do this? All right. CD test. // Okay. So it's still not doing. All right. Let's see. Let's do node // index.js. Is that gonna? Let's see if that works. There. Okay. No such file. Okay, so line 17. Okay. So we have a problem here. What is it? That gonna make it better? Nope, not gonna make it better. Okay, we'll figure it out. Steven, maybe you're in the environment or try using pwd command to see where you are. So it's more about the MCP server you cannot call MPX within the root directory of the original source. So that's the problem. I know it's a very common problem. So npx-y at pubnub /MCP. This will happen when you call it here. However, if you're in a different directory, test like this, is it going to work? No, it doesn't work there. So CD, let's go to desktop / Stephen Coin. We'll go Stephen Coin. Here we go. Does it see? Now it works. There you go. It's the directory, you guys. It's the directory. You gotta be careful. Where you are. So that's the main problem. So what I need to do is, unfortunately, I have to build this file, but then run it outside of the directory. Which MCP? Oh, which MC and give a full MCP is not a real command, so this won't do anything. I'll be surprised if it does. It's not going to. So really what it is which NPX. And so that works perfectly fine. So this works. So this is here. This is, you see, there's no errors. We're looking good here. So that's the problem. So what I'm going to do is I'm just going to move it into a different directory for now. And then we will run it to there. So let's see here. All right. So where should we put it? So let's just say CP test speed boost, and we'll throw it to desktop Steven. And we'll just put it in Steven Coin for now. There we go. We'll just put it in Steven Coin. / desktop Steven Coin ls. All right. Bye. There we go. Let's boot that boot test. All right. And then MV test. What we'll do is we'll move this to here and then ARM directory test. All right. Put the NPX path to it. Then put NPX path to it. NPX doesn't have a path, right? Wait, SAQ 3000. If you have the ability to let me know how that works, I'm actually kind of curious because NPX is not a path. It's a URL, right? It's a URL, and it already works. It works perfectly fine. I'm pretty sure. I feel questions have reached a level that are now being ignored. Oh no, really? Wait, I don't think. Are there any good LLMs that could run on a 6 GB VRAM or no? Yes, I think there's a pretty good one. So I heard this one's pretty good, but I don't know if it's. It might be too big. It might be. It might just be too big. But if you can do GPT OS 20 billion, or I think maybe Llama. I think another one's called Llama. Llama. From Llama 3.1, here you go. This one's got 8 billion parameters. This one's also good. So this one will probably work for you. Or Botomois? What is that one? Wait, Boto. Is that in here? Wait, what is it? What is that? Boto, M-I-S-E. What is this? What is Botomice? It doesn't look like it's a thing, is it? Botis? Is it Botis mice? Okay, I don't know anything. We'll find out. We'll see. Roomba is evil. Roomba's not evil. Well, Roomba could be evil. Good AI is Johnny 5. Yeah, Johnny 5. I remember Johnny 5, Erwin. Oh, the robot that has like it's got like a tread for legs, right? So it can like move forward and back. I remember Johnny 5, the robot. Short Circuit from the Short Circuit movie. It's a good AI. It's basically your Roomba. How's it going? Going very good. Good to see you. So sorry, I ran behind on some of the chat messages because I got distracted. I meant Aristotle. Don't make you lower batter. Oh, okay. All right. Here, let's jump back. All right, so we've got everything we need here. I'm just gonna grab. So we grab that here. CD, desktop, Steven Coin, and then we could just say ./test the boot, and hey. Perfect. Okay. We made it a step further. I think. Okay. It's because we need to do this. Here. We need to update this. All right, so NPX-Y. There we go. Hey, how does it magically know? I like how the AI magically knows. All right, test. All right, so what failed that time? Just CJS loader? Can't find module? Oh, wait, what? Interesting. That's very interesting. All right, so we've got a problem with this. Oh, because of that, you gotta read the code that you're running, Steven. You gotta read the code. All right. Now we're good. Is it gonna work now? All right, there it goes. All right, we made it a step further. We're making progress. All right, so we got about 20 minutes left. I don't think GPT OSS 20 billion is going to fit into my GPU since it's 14 gigs. You might want to run the Llama. Well, yeah, so maybe that one's too big, isn't it? 500 LRB, that one's too big. So I searched real quick. Lasers used to display on its low end if, wait 1 second. I don't know what you mean. Steven, type echo which NPX. Oh, hey, all right, I'll type echo which NPX, but we're good to go. We already got it. Echo, wait, where'd that go? Did you, wait, oh, there it is right there. Echo money which NPX. There you go. I mean, it's the same thing. It's right? we're not. It's the same output whether you do echo or not. It's the same output. But also we're good to go. We're good to go. We don't have any more issues now. We've got it all perfectly fine. So line 16, perfect. Okay. So now what I need to do is figure out this. I want to make sure. We need to make sure that this is what we want because we need to get the input and output for this right here, for this, for the proc itself. And then we're good to go. 1 second here. Let me pull that out. Okay. Put it in the script. Oh, it worked. Yeah, we're good. Yeah, we're good. It worked. Okay. Let's see here. Okay. So, 500 LRB. I'm not sure about another smaller model that is good, right? Because you want something that's going to be meaningful. But I do recommend if you check out maybe if this can work, do Llama Llama 3.31, 3.1 or 3.2 maybe even. Is there 3.2? Is 3.2 available? Here you go. Try 3.2. Here you go. Here, or is this it? Metas Llama. This is it. You found it. This is it. It's not going to be the best. But it's something that will definitely work. Check it out because it's only 2 gigabytes. This is it right here. All right. I'll put that on our Discord chat. I'll put that on our Discord here. Here we go. We'll throw it under free resources on our Discord. So low on GPU RAM, question mark. Try the Llama 3.2 model. Here you go. There you go. It's on Discord, you guys. There you go. I think that'll be the place to go. This is it right here. It has 128 character context tokens as well. So that's pretty good. That's pretty decent. There you go. You got it. Let's see here. Holograms are 3D shaders for real-world vertex transformers, depth buffers, and GPU pipelines converting light into interactive user interface, says Aristotle. I asked AI to help me say something smart. Hey, you did? Okay. So, holograms are 3D shaders for the real world. That is kind of interesting to think about. It's just a weird way to think about it because I understand vertex transformations and depth buffers and GPU pipelines because I've done this before. I've used GPU hardware to accelerate, drawing, make graphics, make games, and AI. So I get that part. I get it. The lasers to display the hologram on the low end, if we want to actually see it moving $250,000, and you will be blinded if you look at the laser. So, moving. That sounds dangerous. Yo, what's happening, Kevin McAllister? Good to see you. Welcome on in. We're doing some bash is what we're doing. We're doing some bash, and we need to get our coproc. So we've got a coproc command here that works really well for our objective. And our objective is to test to see how fast where's our print R here? There's a print R. There we go. Our objective is to see how fast our MCP server boots. So, let's see here. Get out of that. Yep, we're good. Happy. IFS. Here we go. Okay. So this command right here works really well. I love how excited Steven gets. I know Kevin McAllister. It's good to see you. Welcome on back in. We're getting things happening. Things are happening, and we got I would say we got 20 minutes. We've got about 20 minutes, and I got to get going. But it's legal if you have the certificates to operate the high-power laser. It is okay. Interesting. So Kevin McAllister, we're also talking about some high-powered lasers that can generate real-world holograms, and they looks real. It looks really real. It's kind of neat, but apparently it requires some high-powered lasers, and they're dangerous. And it's probably why they put them high into the air, so that way no one would jump into it and get blind and get a plasma burn. Interesting. We gotta be careful. The speed can, but to only be emitted or without burning, that sounds like it's dangerous. It sounds dangerous. Should be a job for styropyro. Wait, with styropyro on YouTube? Wait, what is a styropyro? I've never heard of that before. What is a styropyro? Here, check this out. All right, so let me grab this line really quick. So here you can see our speed. So this is about a second, right? That took about a second to boot. That's decent. That's decent performance. That's decent. And if it's cached, I think it goes even faster. So yeah, so now we're about a half a second. So we're doing good here. We're at about a half second. We're looking good. We're looking good on that. Styropyro is famous lasers YouTuber. Okay, let's check it. Styropyro. Wait, did I spell it right? I gotta spell it right. Styropyro. Wait. Oh yeah, I know this guy. I've seen. Oh yes, he makes a lot of lasers. And I remember this guy. All right. Science maniac loves building huge lasers and playing with electricity and chemicals. I remember this guy. That's so cool. I forgot that it was his name, Styropyro. That's a good name. Yes, definitely. Nice. That was awesome. Thank you for memory lane. I like that. I remember that from so many years ago. That was awesome. All right. So the last thing we need to get here is our coproc process ID is what we need. We need the coproc process ID. I wonder if we could just use the PID itself. Can we use the process ID itself? I wonder if we could. I don't think we can, but maybe we can. Latest video said he has, or are you remembering wrong? That would be terrible. Are you serious? That would not be good. Is it from all the experiments he's done over the years? Dangerous experiments? That would be heartbreaking. That would be absolutely heartbreaking. I hope not. I hope he's okay. All right, so let's try this. Let's go over here PID. There. Is that going to make it better? Let's see here. All right, so we got our process RD. All right, so let's run the test again. Okay. Oh, bad file descriptor. I figured because it's not a file descriptor. You're supposed to say, hey, Steven, you can't use a process ID as a file descriptor. What's wrong with you? Of course not. So what I need to do, all right, so we need, oh, I see. Let's comment that out. We don't want to be running that. Okay. So this is not real, apparently. So I'm not getting the right information. I need, we might be stuck. You guys. DeepSeek 8 billion just barely fits on my GPU, but thanks. Also, you should check out the small LLM. I like the name small LLM. It's extremely funny since it knows like nothing and is only a few megabytes. Oh, is it? So it's actually really small. It's super small. That's funny. Not cancer, but something like high testosterone, which doesn't get used by his body. I think, not sure. Oh, got it. Okay. Got it. It seems like it's a problem. That seems problematic, but it could be okay. What is your making? Oh, Shamu Sconner. How's it going? What is your making? Oh, what are we making? What is it you're making? We are making a benchmark. This is a benchmark that's going to test how fast our MCP server boots. So we've got the command right here. The command works very well. So you can see this command's right here. So this is our command. It actually works perfectly fine here. And then we run it and it gives us the output. And the output that we're looking for is here on the screen. It's kind of hard to read, but you see there, you can see my cursor moving around up here. That is the benchmark. That's the data that we're looking for. And so what I want to do is turn that command into a multi-line command. But right now it's a single line command. Thank you for the likes, you guys. So you know what? Actually, I've got an idea. I wonder if we could just do that. Is that going to do a thing? I don't think so. It's just going to print nothing. So that's one of the problems. So I would like to be able to run this command from a script and have it output to the terminal. The duration takes the boot, send data into the MCP server, and then send data back, and then measure that full round trip. That's what we're doing. So it works right here perfectly fine, as you can see. But now I want to convert it into a nice little script that we can use whenever we want. Why do you need it to be multi-line? I don't, but I also need it to actually work. So you can see here it's one line. I wonder if we could maybe get rid of the shebang. Is that, oh, see, no, it doesn't like that. It does not like that. What if we did bash? It probably just not going to like that either because coproc doesn't exist in bash, right? Coproc doesn't exist in bash. Command not found. Yep, I knew it. There we go. Gotta go back to the ZSH. There we go, Z shell. So now it runs. It works, but it doesn't give us any output. We need to print it. We need to print the timed output. We need to capture the output. I wonder. Time equals money. There we go. Time equals money, you guys. All right, so we say print time. Is that going to do it? Is that going to go to doing it? Is it going to work? Nope, it just prints nothing. All right, maybe we can do some backticks like this. Can we do backticks instead? Is that going to make it better? Nope, no better? Okay, no better. Steven, do you know Llama C++? It's a web GUI is out this week. Is it? Wait, really? I remember Llama C++. Isn't that Facebook's Meta's isn't that for llama? For running the llama model? I thought it was. So you're going to parse the output string and split it. We could maybe pipe it and then do an awk instead. Oh, maybe. See, the problem is, let's try it. Let's try to pipe it. Pipe grep. We would total. Let's do that. Grep total. Let's see if we can grep the total. Let's see if it works. Nope, prints nothing. Let's see. Print time. We don't need time. So see, that's the thing. This is the thing that I'm trying to solve, and I actually don't know what the deal is. So you can see it works perfectly fine right here. Maybe no, it seems fine, but the problem is that it's not printing when I run it inside the script. But also, I would be nice to have it on multiple lines like this. I think it would be really nice to have it on multiple lines. Time in ZSH is built in. I think an actual binary of time exists, which is what Bash used. Oh, really? Okay, got it. I didn't know. Time in ZSH, yep, okay. There we go. I remember Llama C++ enabled using large language models in small specs, using 1-bit LLMs. Okay, 1-bit LLMs, gotcha. So that actually is kind of cool. That's pretty neat. I think that's pretty neat. I really want this command to actually give me the output. I think it'll be fine because I can just document this command. I can just document it in the README and we'll be fine. Actually, that's what I should do. I'll tell you what. That's what we should absolutely do. So this is what we'll do now. We'll just document. Well, for now, we'll make some progress. README. Here we go. All right. So we can say configure. Get past the configure environment. Docker base. All right. Let's put this at. We'll put it at the bottom. We'll say. We'll call this benchmark boot speed. Here we go. Perfect. And then we paste it. Shell. It's the shield. It's the shield. There we go. Grab that. Okay. So there we go. Run this command using ZSH. Yep. To benchmark the MCP server. So that's what we got to do. There we go. So at least we got it documented. There we go. Now it's documented. Now things are bin time maybe. Maybe actually we can try that. We can try it. Let's try it. What? That's so strange. Is that not standard out? It is. It's totally standard out. Have a wonderful day. Not in West. Thank you. Not in West. All right. We got 10 minutes left, you guys. We have 10 minutes left and we got to get going. We got 10 minutes left and we got to get going because we got other things. Other things need to happen. But at least for now, here we go. Benchmark the speed of the tool. There we go. All right. So let's jump back. We can say bin time. I'm sure. Well, time is fine. I think. So here, time echo. So we'll just run time echo and then exit. So that'll definitely work perfectly fine. This will perfectly work perfectly fine. Here we go. Get off the screen. There we go. Test. Perfect. So, oh, hey. It didn't run. What? Oh, all right. Bin time. Let's see if that works. Okay. So which time? Time shell reserved word. It is. Oh, there you go. Your clock says 20 minutes still. I know. It's always. Well, I like how we have a chat meme. I like how we have an official chat meme now. It's official. It's a chat meme because you guys remember it from last time. So this counts as a chat meme. The only live stream I enjoy. Thank you. All right. That's great to hear. I appreciate it. 500. Oof. Trying to get into Bash and running which? I know. Isn't that crazy? So time is a reserved word in ZSH. Thank you for the likes, you guys. I appreciate it. So maybe what we can do, I've got an idea. What if we call Bash? And then we call ZSH from Bash? We can do that, right? We can call ZSH from inside Bash. Maybe that'll work. I wonder. All right, let's see here. Let's get it. All right, let's see. Is it actually gonna work? Oh, wait, no. Here we go. Oh, there we go. Okay, so now we're in Bash. So all we have to do is call ZSH from this. All right, so how do we do that? How do we call ZSH? Do we say -C and then put like some quotes in it or something? Shell inspection. This is what we're going to do. We're going to do cell inception. That's what it is. We're doing cell inception. You got it, Kevin McAllister. We're going to use some trickery here in order to get the exact output that we're looking for. All right. Now we're going good. All right. So let's see here. How do we? So ZSH-C echo 1. Is that gonna work? Okay, so that is exactly what it needs to be. Is it -C? Right? It's -C. Yep, it is. It's -C. All right, we've got our command. We've figured it out. The only thing is, I need to escape some of my symbols in here. I'm pretty sure. So let's do this. We'll do single quotes, and then we need to find our reverse. There we go. So escape that, and escape this here as well. There we go. All right. Is it gonna work, you guys? Is it gonna work? I don't know. Oh wait, no. We have to run time here. There we go. We run time right there. Perfect. All right. This might work. Bash better than ZSH. Hey, there in some cases, you're right. SAQ 3000. That's the way. Why not the other way around? Do ZSH shebang and then bash C command here. Could we do that? No. See, the problem is coproc doesn't exist in bash. So bash -C. So watch this. Bash. So now we're in bash. So say, watch this. Coproc. Coproc's not found. It's not. Coproc doesn't exist. Coproc doesn't exist in bash. So we have to do it this way. We have to do it this way. All right, here we go. Is it going to work? I don't know. We're going to find out. Oh, okay. Syntax error. What is, is it because, is it because, wait, it's talking about line 13. So it must not have escaped properly. It must not fully be escaped properly. I'm wondering about it. So I wonder if there's, maybe we can do, no, we need it to stay, we need it to be within single quotes. In bash, even PS1 final. PS1 final. If you run time echo hello, ZSH prints the output hello and does not display timing information because echo is a shell built in and doesn't create a separate process. Oh, there you go. Configuring your bash RC. Hey, I've got a ZSH RC. I've got a ZSH RC, which I will not show on stream because it's got things inside it that we should not share. In bash, even PS1 failed. Okay. Failed. Got it. It failed. Okay. So let's see here. Let's do some debugging here. ZSH, 20 minutes left. Actually, we've got 6 minutes left. ZSH-C, and then we just say echo 1. Oh wait, we did it the wrong way. Oh, we also got to type it right. Okay, so see, that works perfectly fine. So it looks good there. Process NPX, process ID. Maybe, I don't know. Do we, see, here's the problem. I don't think we want to, asking for AIs to codes. Wait, what do you mean? Can you try, time command cat? Sure. Time, might as well. Well, let's see what happens, Kevin. I'm actually kind of curious. Time npx-y at pubnub /MCP. And then you said, cat. Sure. All right. Well, let's cat. There we go. Did I type it? Let me see if I typed it properly. Type space cat. I don't think that's going to work because our MCC server does not close. It stays open. So that's one of the things. That's why we need to use coproc. So this is one of the reasons why we are having some challenges is because we have to use coproc to create 2 separate file descriptors for input output for redirection, because as you can see here, the MCP server command is a process that stays running. It stays running until you close it. So it won't close like a normal process because it's meant to be as a server. It's a JSON RPC server. So that's what it is. No, he wants to use echo before, not cat for the pipe. Run the script explicitly in ZSH, not bash. All right, let's try it. We'll see what happens. ZSH RC. Well, actually, I'm kind of curious to see if that's going to do anything. Is it? No, well, something happened. Unmatched. Is there? Wait, hold on. Let's double check. Looks good. That's totally fine. What do you mean unmatched? It is matched. What are you talking about? Do this. Maybe while read, do echo. Done. I mean, that'll work. That'll work perfectly fine. That will absolutely work. It will. Actually, that might be a good idea. Okay, SAQ 3000. Let's see if we can make this work. in a very short time span. All right, so let's see if we can get it to work. All right, so let's do this. Let me copy this real quick. Export tools. All right. So echo money tools. All right, let's see if this works. Maybe we can get it to work. All right, so there's our tools. So what we can do is echo money tools to npx-y at pubnub/mcp, and then you said pipe it to while, maybe ifs equals while, and then read x, do echo money x, done. Let's see if we can capture it. This actually might work. This might actually work. We also need to capture the process ID. This might work. Let's see here. Nope. No. Wait, near while. Wait, why is that? No? Oh, because, well, let's see. Let's get rid of this real quick. I think actually probably we could put that up here. IFS equals space echo. Okay. Hey, all right. So far, so good. Let me see if we just say echo got it. If this works, if we see got it, we did. Okay. Hey, you know what? SAQ 3000, I think we're making a lot of progress. So what I need to do, see, the problem is I need to capture the process ID. We need to capture the process ID for NPX because we need to close it. So we need to close it afterwards. We need to close it. So how do we grab that? How do we close it? So can we do time? There we go. Time, got it. Okay, so good so far. All right, so far so good. Now we need to capture the process ID, and then we can exit. So like, isn't this cool? All right, so we're good. We're doing good. All right, so we need the process ID. Can we? I don't know if we can. Can we ampersand and then get PID equals money exclamation point? Can we do that? Is that possible, or is that not going to work? It worked, but the problem is that it's how do we grab that? How do we get the process ID? So we're in a weird spot right now. Maybe we can do this. No, see, we can't do this because this is blocking. It's blocking. Wait, use money. Okay, use it like that. I don't know. It's blocking is the problem. See, the problem is this is blocking right here. So like this will block. It blocks. See, it's not gonna. So this is why we need it to be asynchronous. We got really close. We just need to. I suppose we could do no need of IFS. Do this time commands. Okay. Let's try this. No time. Well, do time in command like that. Okay. So there it is, right here. So we have to echo tools like this. We have to echo the tools. So the problem is now that we've done this, it blocks. See, this is the problem. It blocks now. I'm being ignored just like the other guy. Oh no, sorry about that. I apologize. I missed your message. Steven, can you open a bash shell and run which time? It won't work because, well, actually, let's try it. We'll try it. Here we go. Bash and then which time, type which time is right there. It's right there. That part's fine. We don't have any problems with that. How many years you been programming? Hey, how's it going? Log ZZ Gaming. A few decades. We've been playing a few decades, and we still struggle every single day. It's still a struggle. See if you can use a real binary. Can't even check myself. So hey, we're good on that part. You're running this inside ZSH, but sometimes the syntax, probably the quote mismatch. Yeah, that's what it is. And the coproc caused by ZSH not actually create the coprocesses. Oh, is that what that is? Okay. All right. We almost got it. Time echo done. Oh, okay. Let's try that. Okay. Time money. I mean, that's definitely going to work. That part will work. Fine. This will work. Echo 1. I know that'll work. Done. Well, we don't need to type done there. But that's not going to work? Wait, why doesn't that work? Oh, because it's trying to execute 1. It's trying to execute 1. So we don't want to do that. We don't want to do that. We don't want to call that. But so that's a problem. That won't work. So what we need is, the problem is this right here. This is a server. This is a server that blocks. Put the whole command there inside. So we I guess we could try it. But it's not gonna work. It won't work. But I'll show you. All right. So done there. Okay. So here's the whole command. Here we'll do the whole command like you're describing. Here's time, and we'll just get rid of this like this. All right. So time in px grid, and it's not gonna do anything. It'll just hang. It'll just hang. See how it just stops right there? Yes. All right. So that'll just hang. It won't work. It won't work. I do have to text. So we're overtime now, you guys. We're overtime. We got to get going. I do have to get going. But the good news is, can't you just put proc inside there? Maybe. Oh, let's try. Let's try it. Function F2. All right. Get rid of that. All right. So paste that. Wait 1 second. Why is that? Oh, no. Okay. Let's go ahead and let's grab this here. So this command works as intended. So let me double check. So this is the command we want. There we go. Does that work? No, we need to get the command back that works. Where is that at? So this isn't where to go. Where's the command at? Here, let me just undo this. Let's just undo all that. Here we go. Time. Is this it right here? All right. This works. All right, that works. Okay. So you're saying do this like that. Time like that. You're saying this is what you're saying. So the whole command in there. That doesn't. The problem is that now it doesn't work. That's the problem. Can't. So that's the whole command. I think so. Yeah. So it kind of worked, but it didn't give us the output that we're looking for. So we're really close. So here's the good news, you guys. Here's the good news. This command works exactly the way I want it to. It gets us the performance metrics that we're looking for. The only thing is, I'd like to be able to run this command and give it the output in a script file so that way I could use it from later. Although we don't need it. It's not necessary. 1 second. So we got a couple minutes left, and then I got to say goodbye to everyone. So I'll say goodbye to you guys here in a sec because I got to get going. We're in overtime now. Rock 30. Smiley face. There we go. Is this the right one? Yep. Okay. All right. So we got to get going, you guys. So use in end while read x, do echo x, done. See, the challenge is that using the end, the challenge is 20 minutes. I know, Tara, we got 20 minutes left. I like how we've got this. It's really satisfying that we've got like a legit chat meme now. We got like a real chat meme. I think that's really neat. 20 minutes left. Yeah, we're overtime. We're overtime, you guys. So I do got to get going. It was great to hang out with everyone. Thank you for hanging out with me and trying to debug this fun shell script command. But we got it working. So the good news is we got something that looks good here. It works fine right here. It's perfectly fine, but I would like to make it better, right? I want to make it cleaner, improve it. So see, you can see these outputs here. You can see the process ID and other things like that. This actually gets me the data I'm looking for. So it legitimately gets me the data I'm looking for. I just wanted to make it better. Hey, how's it going, Mr. K? You got here right at the very end. We're headed out now. Thank you for all the likes, you guys. All right, we'll be back tomorrow. I think we're going to be back on our blockchain. We'll be doing more Rust tomorrow. The plan is for more Rust tomorrow, everyone. Thank you for spending time with me here at the end of the day. We're going to click the stop stream button now. We'll be back tomorrow. See you then. We'll be back tomorrow. Bye, everyone. See you tomorrow. Bye, guys. Thank you for all the likes.